Morning, everyone. Um, I trust we all rested well, and we are ready for today's class. So today we'll be talking about upgradable smart contracts. Yeah, we won't dwell long on the theoretical aspects, so we'll just go into the practical aspects like in the next 10 minutes. All right. Okay, please let me know when you can see my screen. Those of us online.
Hello, I can see your screen, yeah.
All right. Thank you. Today we'll be looking at insights on upgradable smart contracts. That is, we would understand smart contracts and how to upgrade smart contracts and what the term upgradable smart contract means. We'd also look at writing and deploying smart contracts. Another objective is to look at the risks and benefits of upgradable smart contracts. And lastly, we would look at managing upgradable smart contracts. All right, so these are what we'll be doing today. Now, what are upgradable smart contracts? If you can remember, as we know at this particular point, smart contracts are immutable. And I believe we know what immutable means at this particular point. Yeah, we can just give like a brief definition of immutable. When we say smart contracts are immutable, what does it mean? Just, yeah, you can just speak it out. Okay, something that cannot change. Right, all right. So once it's deployed, you cannot change the data stored or the contract. But then there are scenarios where you have bugs. What do you mean by bugs? Bugs are unwanted errors or wrong flow, something that isn't working according to plan. You have probably you are building a website, and your website, if you the flow is once you click on a button or you fill the form, it's supposed to submit to the server, but then it's not submitted to the server. That's considered a bug. Now, there are scenarios where you could push a bug alongside your code into your smart contract. If you push a bug alongside your code to a smart contract, how do you fix it? Since it's immutable, that's where upgradable smart contract comes in. Or if you want to add new features, how do you work on these new features and add it to your smart contract? This is where upgrade comes in. Now, to understand these upgradable smart contracts, you need to understand that upgrades don't change the code. What they do is they offer a way to preserve the state, address, and balance. There are several ways to achieve this. So you need to understand that, okay, when you say upgradable smart contract, it doesn't necessarily mean changing the code of the deployed smart contract also. What it means is that it kind of offers a way to preserve the state. So everything you have stored on the blockchain via your smart contract, it can be accessible and preserved. Same thing with the address and balances. So that's upgradable smart contract. Now, how does um, upgradable smart contract work? There's the proxy contracts, right? So what they do is they act as intermediaries or delegates that forward calls to the actual logic contract. Now, those of us coming from the Web 2 background, I'm sure we might have heard of a proxy server or even playing around with your phone. I'm sure you'd have seen something like proxy or so. Now, in the real life sense, proxy means what? Like delegating authority, like a substitute. So if I say I want to carry my partner as a proxy, it means it's going to substitute for me for whatever task or assignment. Now, likewise in server, when you see proxy server, even in the Web 2 space, what it means is it kind of acts as the middleman between the client and the server. So in the scenario of your front end or back end, your browser is the client and then your back end is the server. Now, proxy in most instances is like the intermediary that stands between the client and server, and that's how it works. Now, in terms of proxy contracts, they also act as intermediaries or delegates that forward calls to the actual logic contract. So you're not making direct calls to the actual logic contract. You're making the call to the proxy contract. That is going to act as the middleman. And then what it does is that it now forwards the call to the actual logic contract. Now they allow for the replacement of the underlying logic while remaining the same contract address. So what that means is the underlying logic, since you're making a call to the proxy contract instead of like your normal direct contract, you're making a call to the proxy contract. It means you can now make a change to the underlying logic while still retaining the same smart contract address, which is the proxy contract. You get? So this is let me just give like this kind of example. What it means is um, you are performing a business with someone. There's a middleman. You that is buying, you don't really know the seller, but you know the middleman. Now, in a case where you want to change, the middleman like wants to change, probably the owner of the business wants to actually change the seller, or even the middleman wants to change the seller. You can actually change the seller, and then you that is the buyer won't even know that the seller has changed. So that's how this proxy works. It acts as a middleman. You can change the underlying logic which the middleman calls whenever you make a call, while still retaining the same contract address. Now, this also facilitates, so you can upgrade your smart contract without affecting the contract address seen by users or other contracts. So when you are developing or even in live production, you can actually make changes underlying, you can make underlying logic changes and all. And you can do all of this without affecting the contract address that are known to users or even by other contracts. So when users are making use of your smart contract address, you can actually still make changes and you don't need to change the contract address that the users are using. So that's how proxy contract is. Now we have internal storage contracts. They kind of work with the proxy contracts. They are used in conjunction with the proxy contracts. What they do is separate contracts are dedicated solely to storing the state data of the main logic contract. So what this means is if you are building your contract, you are going to have a separate logic contract, and then you also have a storage contract. What the storage contract does is that the purpose is to store the state data. So you are going to store every data that is going to be performed is going to be stored on this contract. It's going to be separate from your logic contract and your proxy contract. So that means in this case you're going to have three contracts. So you have your logic, your proxy, and then you're going to have your storage contract. Now, this also facilitates upgrading the logic contract without compromising stored data. Now, the main thing is we know the data is immutable, right? So, in a scenario where you would want to upgrade your contract, how do you do this? What you do is you create like a separate contract, which is like the storage contract. That contract is going to be used to be stored, is going to use to store data. And then you are now going to have your logic contract. Your logic contract, you can always make an update to it, you can upgrade it, you can do whatever to it. But at the same time, your data won't be lost. Do you get? Now, I'm sure in our previous classes, every day we see how we make changes to smart contract. But we notice at each point where you make a change and you redeploy, the previous data is lost. And you are giving like a new smart contract. So in a scenario where you want to actually make an update to that without losing your previous data, or let's say your previous balances and the rest, this is a flow and this is what you can actually do. So I would actually like us to really pay close attention. Thank you. All right, and then it also ensures persistence of essential contract data during logic upgrades. So now, using when you have like a separate storage contract, as I've said, you can make logic upgrades, and you're certain you're going to your data will be preserved, and then it's also used in conjunction with proxy contracts to maintain state data across upgrades. All right, so I would try to rush through the rest so you can actually move to the practical. And then we have logic contracts. So these are the contracts housing the actual logic or functionality of the application. Separating logic from other concerns allows for independent upgrades, enables modular upgrades without affecting other contract components. Just like I've said previously, you are going to have different contracts doing different things. One is going to be your storage, one is going to be your proxy, and then lastly, you're going to have your logic contract. I believe at this point you understand what logic contract means, often logic in writing of smart contract. Where in our control flow that we did last week, we explained how your flow of smart contracts is and how you can control the flow of your smart contract, the execution of code and the rest. We did that last week, so I believe you should understand what logic contracts mean at this particular point. All right, and then so we're looking at writing and deploying smart contracts. Creating and deploying upgradable smart contracts involves specific design principles, coding practices, and deployment strategies to ensure flexibility and maintainability in blockchain-based applications. So there are certain design principles and coding practices you would have to follow. We'll see that in the practical section. In terms of designing upgradable contracts, from seamless upgrade, it is important to modularize and implement upgrade mechanisms ahead of time. Tools like OpenZeppelin and others are useful for deploying upgradable smart contracts due to the availability of plugins. We have made use of OpenZeppelin before to deploy a contract. ADAT, I believe from next week, we'll be looking into ADAT. So all these, there are tools that can actually help you in deploying your upgradable smart contracts. That's because they have like a vast amount of plugins you can maximize and make use of. Now, it is also important to modularize and implement upgrade mechanisms ahead of time. What do we mean? It means you don't have to wait till a need comes before you start working on the upgrade mechanisms. You can actually lay the foundation at the architecture right from the start. So in scenarios where you want to fix bugs, in scenarios where you want to add new features, you don't need to start rewriting, and then you can just go ahead to make your changes to your logic contracts. Now, what are the risks associated with upgradable smart contracts? One, security. So increased risks of introducing bugs or vulnerabilities during upgrades. Remember, we are making a change to the underlying logic contracts, right? So there's a chance or a risk of introducing new set of bugs or vulnerabilities during upgrade. And then another is data integrity. So this could actually lead to data inconsistency or loss during the upgrade process. There are scenarios where you can lose your preserved data if you're not careful. So that's why you need to pay like careful and close attention when you're performing an upgrade. You need to be careful and you need to know what you're really doing before you go ahead to upgrade your smart contract. Now we have seen the risks. What are the benefits? Benefits are flexibility and adaptability. So the fact that you have the ability to modify, upgrade, and enhance contract functionalities post deployment, I think that's like a good thing, I believe. So you know you have the chance to solve or even like in cases where there are new bugs or even in cases where you are trying to reduce the gas fee. Maybe after deploying, you realize gas fee for transactions or for users is quite high. So you can actually go ahead to make changes or upgrades. And this is the flexibility and adaptability benefits of upgradable smart contract. Another is bug fixes and enhancements, address bugs, improve performance, introduce new features without redeployment. And then lastly, we have long-term maintainability. So you can maintain it for a long period of time, as far as um, okay, you can sustain relevance and
So that's it. And one thing again you can do is that you can try to now check the age that is inside contracts, whether the age is now 17 or not. You can see that, oh, the age is 14. Sorry, I'm using something require that age. Oh, sorry, we didn't actually copy the right address. Let's try to get it. Need to copy it. Then have this. Over that. Let's transact. You see, it's went through age. Let's try to set it to and say age. What I'm expecting is to see 30, right? But you not see 30 because it's not successful because the age is not greater than 18. Then I try to say transact. Let's see the age. It's still working. I will be see something here. Let me scroll down, sorry. Find that age is greater than 18. Can set. Okay, let's try to check it very well. Let's check the credit contract. Okay, let's come here. A V2 upgraded deploy. We have a new contract request. Right. Let's come to paste the new contract address and set it to transact. AGC 30. Oh, my bad. I'm very sorry for that. It's still working. I have to check that. Uh, but I don't check it. It's now back on that. So let's just something like this. So let's try to do this number again. So what to do now is that I want to deploy the contract again. Let's close every tab and say contract AD, right? is that you copy the address of A, put it 800, let's transact 100 because the code inside A got to it works just like that. Let's try to deploy the upgrade, sorry. Come here to this content set. Click on age, you should see 60 because the code inside the upgrade is equal to age times 2. Times 2. You have something like that. So now 2 for V2. Have baskets. So the problem is actually from here, not so. Sit down. Now deploy this V3 now. See that this is also of time cross deploy it. This set age. I click on transact. You can see there's an error. An error is that it failed. When I click on age will not be set to any value like to see on that tweet. Let's do transact, see it is reverting. Click on age is still 20. So that's how it works basically. And I will try to go over it one more time. And if you have any question, please feel free to ask me. So what we have here is we have a contract A. This contract A is a contract just like every other contract. But this contract B is another contract that is calling on A in its own context, like is executing all the code inside A in its own context. So instead of modifying the state variable inside A, if you start modifying the variable inside, meaning that if this A, they should take problem with this A tomorrow, can this and continue with what with the upgrade version. The upgrade version underscore times 2, which is like a modification of earlier. So now, if this upgrade looks exactly like the other by doing something, maybe instead of having this one, you can just can also do something like that. Something like that, right? Say implementation is equal to implementation. So that's just how it's operating. Now with this, anytime you upgrade the contract, tell the new address of the new contract. And one thing is that this B address is what you send to your users. They don't need to know about all this A, they don't need to know about A upgraded or AV2. All they need to know about is this B. Even though you are checking the code that this B is running, the address of and also something will not change. And also it will really help you with upgrading the code. But there are some rules. First, when you have something like this A, look at this A. The first variable is called age. You cannot come here and have something else like address. It's not possible. It's not going to work because so the slot address is what is used to like modify the data. So if you try to put it to work, so that one thing about operating Solidity. So that any call, please, so that any question, please can unmute and ask. I'll be happy to take it. So that so if you have any questions regarding this contract, please ask now so that I can take it. This is just a very simple way of explaining operating smart contract. As time goes, subsequent classes, we are having using EtherJS and HADAT combined with OpenZeppelin upgradable smart contract to create different kind of upgradable smart contract. So if you have any question, please ask so I can take it.
Can you go over it again? Can you go over it again?
Good morning. Good morning.
Sorry, my question is during building setting the smart contracts, are we going to set the contract once like the contract A, contract B, contract A, or is it when you want to upgrade that you add the next contract?
Okay, so this is what I'm doing now. I'll try whole project and then I'll use another example so that you can understand the way this thing works very well. So this is what I'm going to create a new folder. I'm going to call it donation. I can see my screen very well, right? So in this contract, we have, let's say we have donation also. Then there's going to be another contract called donation V1. So now, what we can do basically is by what we can do now is that we can have V1, this donation contract. Let's now contract where we used to do it so we can understand it from another perspective. So we have V1 and we also have donation. So I'll paste the code here, then I'll write in the contract. So I'll say donation rate. Then I'll say that you receipt amount, so just say progress. I don't want to make very simple. Then there's going to be a function called donate. And you can typically donate any account to stop, which is and it is payable. What we'll do now is that we'll now say that we have another variable, you can note down address. So yeah, that's kind of just the implementation or some implementation. The implementation contracts, I can write all the logic for this donate, but inside this donate, this donation system, you can